So ATP related to the topic current, voltage and resistance. The electricity experiment like connection of a voltmeter, ammeter is important and how to read them. Better go through these points before starting. Question one, some students are investigating a relation between a potential difference, which is a voltage, and the current for a resistor. They use the circuit as shown. The crocodile clip is there. What is the advantage I hear? Like using a crocodile clip, we can use different length of this wire. As you can see, a sliding wire is there and a crocodile. If we clamp here, the crocodile clip, so this the effective length which we use for the experiment, if the according to this figure, the crocodile clip is positioned here. So this is the length of the wire we are using. But what if we change the position of a crocodile clip? Then the length of a wire which we use for experiment will change. The crocodile clip is connected to various position on the sliding wire. The current and the potential across the difference across the resistors are measured. The reading on the potential the reading of potential difference voltage and current for a various position of a crocodile clip are there in table 1.1. Draw arrow on figure 1.2 and 1.3 to show the meter reading for a value in a first row. In a first row, the voltage is 0.4 and the current is 0.8. You have to draw a needle to show, you can use a screen annotation, draw a needle to show 0.4 volts on the voltage and 0.08 for the current. Use a screen annotation where is 0.4 on the voltmeter. You just have to do 0.4. That will be 4.4. It's only 0.4. So when you draw, yeah, that's right, because each is representing 0.1. So 4 lines equals to 0.4. So this is 0.4. Then here use screen annotation to mark 0.08. 0.08. Not 0.8. 0.08. Zero 0.08. So it will be here. Why? Because there are like 5, this is 0.1. So 0.08 is less than 0.1. So, and there are representing the 5 lines from 0. So each line is representing 0.02. So this is 0.02, 0.04, 0.06, 0.08. Yeah, 0.02 per line. So that's why 4 lines after that. So when you draw, it's when look, this is a pointer. So the best way, you start with a point, and then this was 0.4 we have to show. So we add 0.4. And this was 0.08. So this will be 0.08. So these are like free marks in which you have to just draw an arrow to show the positions of the needle. Then we have to plot a graph for these values. We have, I will note it down these values. So 0.4, 0.8, and voltage is on y-axis. 1.2, each like 1.4 difference is there between each. And the current is on x-axis, they mentioned 0.08, 0.17, 0.25, 0.34, and 0.41. So first we have to label the axis. On x-axis, we should have a current. On y-axis, we should have the voltage. So this one, how to label? One mark is for just labeling the axis. So this one is for current, as I mentioned, and the unit ampere. This one is for voltage and the unit is volt. So for voltage, I need from 0 to 2. So if I select like I need from 0 to 2 and try to cover 70% of your graph paper or more than 70%
So,
of your
Mr.
graph.
Can we use the 0.01?
Yes, you can use 0.01 like 0.1, 2, 3. If you select 0.1, 0.2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be 1. Then this will be 1.1, 1.2, 1.3, 1.4, 5, 6, 7, 8, 9, and 10. So this will be 2. So this is a voltage. For current, the smallest value is 0.08 and the highest is 0.4. So I have to reach till 0.4. So if I select each box as 0.1, so this will be 1.1, 2, 3, 4. So if I select this as 0.1, like 10 boxes equals to 0.1, each box is 0.01. Then so this one will be 0.2. So this one I select as 0.2. Then this I select as 0.3. Then this will be 0.4. So on x-axis, I took 10 boxes equals to 0.1 on x-axis. On y, this you don't have to label, mention the scale, but if you mention, it's fine. Like you can mention here, the scale which you select, that you select that 10 boxes equals to 0.1 on x-axis, and on y-axis, you selected 20 boxes equals to 1. Or you can mention for one box as well. Like this is a scale for 10. I can even say one box equals to 0.1. Here, or two boxes equals to zero point 0.1. Then we have to mark the points according to the values. So 0.4, when the voltage is 0.4, the current 0.08, this will be 0.09, this will be 0.09, 0.08, and 0.4. So this will be 0.1, 0.2, 0.3, 0.4. Then 0.8 and 0.17. So 0.17, this is 0.19, 0.18, 0.17 is there. And this was 0.4, 5, this is 0.8. 1.2 and 0.25. So 0.25 will be 5 boxes, 1, 2, 3, 4, 5. And the voltage is 1.2. This one is 1, 1.1, 1.2. Then we have 0.34 and 1.6. So this was 1.2, 3, 4, 5, 6. And then 2 and 0.4, 1. So 0.41 will be. This is 0.41 and this will be 2. I think this one. So these are the points we mark according to the values given. In which we were having this was a voltage and this one is a current. Then after labeling, determine the gradient and show clearly how you obtain the necessary information. Like, so what we have to do, we have to draw a line of a best fit. As we know, current and voltage are directly proportional. So there should be a straight line which is passing through origin. So number of the points appear above and below should be same. And when you're finding a gradient, take any 2 points on the line. But it's not like take the same point which you use to plot a graph. That is not the right way. The formula for the gradient, it is y2 minus y1 over x2 minus x1. So what you have to do, you have to take any 2 points and show them like what points you took. Like I took these 2 points. And say this is a second. So you have to draw these lines to show that what point you took. Then the first point, on x-axis is x1. Why you cannot take those green points which I marked? Because these points maybe the point may have error. That's why, like student, you can also use 0 as a point. 0 be a point. 0 can be a point. The best thing, you can take 0, so it will say make it very easy to calculate. You can take 0 as a point as well. That's fine. So this will be x1. This will be y1. X1 is 0.1. This is 0.1, 2, 3, 4. Example 0.5. This one is 0.3. X2, which is 0.39. And y2 is equals to 1.9. So we have to use a formula for the gradient, which is y2 minus y1 over x2 minus x1. So we just substitute the values for us. The y2 y2 was 1.9 minus y1 was 0.5 divided by x2 is 0.39 minus x1 is 0.1. So the gradient, this will be 1.4 and 0.39 minus 0.1, which will be 0.29. So 1.4 divided by 0.29. What's the answer for this? The value for the gradient?
Equals 4.82.
4.82. So the gradient here is equals to 4.82. So you will write here 4.82. Then they mention the resistance value is numerically equal to gradient. Like means the value of the G is equals to value of R. So what is the value of G? Value of G is 4.82. So what is the value of R? The value of the R will be 4.82. But you have to write the unit, that is ohm. Then students suggest that the potential difference and the current for this resistor should be proportional, like two are directly proportional. State whether your graph support this suggestion. We are getting a straight line passing through origin. Are they directly proportional? Yes or no? What we can say? Yes. So, and what is the reason for that? Because it's a straight line passing through origin. Whenever two quantities are directly proportional, so statement you will say
You
yes,
can
they are
also
directly.
mention uniformly.
Yeah, but to be directly proportional, the main condition is start from origin. Even it's a straight line, if it does not start from origin, we don't say they are directly proportional. So yes, yes, here even you can write yes, voltage and current are directly proportional. And the reason is that because it is a straight line with constant gradient passing through or starting from origin. So whenever two quantities are directly proportional, there must be a straight line and that straight line must start from origin. But what if there was a graph between the two quantities? It was, say, straight line, but not from origin. Are they directly proportional in that case? Yes or no?
No.
No. Because it is a straight line, but it's not starting from origin. Same thing, if it was a straight line on x-axis, again, it's a straight line, but not passing through origin, so they are not directly proportional. So condition, statement, straight line passing through origin, they are always directly proportional. Student notice that the sliding wire become very hot during the experiment. Suggest a change to the apparatus or a procedure that might prevent. Like usually electricity experiment, this is very common thing. Like even if you're using your mobile for a very long time, it will become hot. Same or its temperature increase. If you're using any device,
Can we say
electronic,
increase cross-sectional area of the wire?
increase cross-sectional area, which will reduce resistance, or use low voltage supply. But here the what we want, but if you increase the cross-sectional area, the resistance will decrease, so current increase. If the current increase, the heating effect will also increase, because the heating effect, the heating effect is directly proportional to the current. If more current is there in a device, it will produce more heat. We want to prevent, we want to reduce the heating effect. So what we should do? Increase the
So
area.
we can reduce cross-sectional area.
So either we reduce cross-sectional area, because when we reduce the area, the resistance will increase. If a resistance increase, what happened to the current? The current decreased, so it will produce less heat. Or you can use low voltage supply. If you use low voltage supply, less voltage, less current, so less heating effect. Or there's also another way, we can switch off the circuit between the readings so that like it will cool down. So switch off the circuit between the readings so that it will cool down or it will not remain hot for a longer period of a time. Is it clear?